Wait, where'd it go? Hang on. Let's see. Oh, maybe it's up here. Okay, so does anybody have the worksheet from the other day? The aggravating worksheet? You may have, but I doubt it. You probably like took them and burned them or something, because they are. I do it intentionally, and you saw that I was like fussy and adamant, and you can't do this and you can't do that, and you must do this and you must do that, because to make the point clear. And Brand, you may have missed it. What happened was they had to find about 20 points for like 6 or 7 graphs. And so I'm going to get Julia to call them out to me in just a minute, because I think she found hers, okay? So we're learning to graph y equals like sine x and cosine x, okay? All right, Julia, do you have your list of points for the first one?
I do.
All right, so here we go. Aggravation is about to set in. Will you read me, started at 0? No, I'm going to do it. You're just going to tell me the points. Like, was your first point in the chart 0, 0?
Yeah.
Okay.
So am I telling you the y or the x?
You're going to tell me both.
Okay.
All right?
Pi over 6 and then 0.5. Pi over 4. 0.7. Pi over 3. 0.8.
Okay, now let's pause for a minute. Okay, so what's happening is we know the sine of pi over 4 is square root of 2 over 2. But where in the world would you put that on your, because they had to graph them after they found all the points, okay? So how in the world would you know where to put square root of 2 over 2? So what we did was they were punching them into their calculator. So they just put in sine of pi over 4, and the calculator has to be in radians right now, okay? And so we got 0.7. Right here, girls, looking right here. If you actually compute square root of 2 over 2, which is the sine of pi over 4, you would get 0.707, okay? Right here, y'all have learned that the sine of 60 degrees, or pi over 3, is square root of 3 over 2. Square root of 3 over 2 is 0.866. So do you see that Julia's given me estimates, because all we're wanting to do is plot it somewhere. Is everybody okay with that? Okay. Obviously, I'm doing this for a reason. First of all, one thing that I was fussy about the other day was the ones that were doing the TPs, the V shapes. Can y'all see this starting to curve already? That's why I make you do it, so it really sets in your head. There's a lot of reasons I make you do it. All right, the next one is probably pi over 2, 1.
Yeah.
Okay. Sine of pi over 2. Sorry, I messed up. Is 1. Okay. And Julia next.
2 pi over 3. 0.86.
Okay. All right, next.
3 pi over 4. 0.7.
Oops. Option P.
And then 5 pi over 6. 0.5.
6. Okay, and
Pi 0.
all right, pi 0. All right.
7 pi over 6 negative 0.5.
Whoa, I hit print instead. All right, 7 pi
Over 6
over 6
negative 0.5.
point 5. Okay, as you were doing this aggravating thing that I know I just reserved one day for y'all to made you in the groups find all of those points. And after a while, some people finished sooner than others because they found out what was happening. You were getting the same points over and over again. But we still can't, even though you're doing that, that's great. We still can't resort to the V-shaped thing, which Ben may not know what I'm talking about, but we'll get there, okay? You see it's very curvy, snaky right now. That was one reason I made you do it, okay? Because these are going 0.5, then a little bit 0.7, then a little bit 0.8, and then to 1, and coming back down again. Now these are going into the negatives. Look at this number right here. This is 1, 2, 3, but do you see that purple dot's a little past 3? Guess where that is? That's at pi, okay? Which is halfway around your circle. And what is sine? All students, positive. And now when I'm passing pi into the third and fourth quadrants, heading toward 2 pi, do you see why I'm going into the negatives? Yeah. Sine is negative down there, okay? So this is like if I brought a slinky up to class with me, okay? So if I brought a slinky up to class with me and then I did this, you'd see that circle that we talked about, all students take calculus, but if I do this, don't you start to see a wave? Or if I take a spool of ribbon that's wrapped up for a long time, and then I start to pull on it, and I just let it lay across the floor, what will it do? Won't it go up and down and up and down? Do y'all know, like curling ribbon, do y'all know what I mean? If I had, maybe you don't know what I mean, but do some of y'all know what I mean? If I, maybe you have it wrapped in a present, like I have.
This? Like you do this with the ribbon?
No, just if I had a spool of ribbon and I just pulled it off and let go of it, it would kind of hold its curvy shape. So that was a bad example. So let's go back to the slinky example, okay? So while I'm doing that, watch this. Or before I go back to that,
What's the worst thing you can do?
I literally am signed right now over here.
okay, I wish I could slow it down some.
So nice.
There's one I can find that's slower. Girls, watch. There's one that I can find that's slower. I'm sorry, this one's going so fast. Maybe I'll look for another one in a minute. But can you kind of see from there? All right, so do y'all see what's happening? You can even watch. Let me get a slower one. Let's see. Oh, this one's great. But you need to be watching, okay?
Oh my god, that is so satisfying.
Yeah, it's really great. Okay, this is sine. If you're watching, sine is opposite over hypotenuse. So I'm going to be pointing right here when it gets to me. Sorry, Elena, maybe you can see here. Do you see how my y grows for a minute? Oh, whoa, hang on. Do y'all see right here? My y grows positive for a while till it hits pi over 2. But then what is your y value down here? Negatives, but all of the numbers are just repetitive, aren't they? So when you graph, it goes 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Like if I was Dr. DeLolio, okay? Dr. No, we'd be in horrible shape as a music department. But anyway, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Because our quadrants go 1, 2, 3, 4, 1, 2, 3, 4. Okay? So this is like awesome to see. This is what's happening. It's just unraveling the circle that you already know about. And those numbers are going to happen over and over again. It's like this. Oh, y'all can send me pictures of plays that you've been in. I think I really need Peter Pan. Actually,
This is my time to shine.
Send them away. Isn't this the cutest thing?
Is that Morgan? It is.
That's Morgan, Ellie, and Stella.
We can definitely arrange that.
Isn't that cute? Yes, we need acting. Okay.
I was Angel Gabriel.
Let's see, who just walked in? Julia?
I played
Okay, so I found a slower one. And while you were gone, I was talking about is sine. Look at your y coordinate. opposite over hypotenuse. Right here, do you see how it's positive and hits its peak and then it goes back down? Then it goes into the negatives, and you could just watch it unravel for a minute. That sine wave will go on and on forever. Here's something, every now and then I talk about philosophy and things that blow my mind, and why I love teaching mathematics, and it kind of blends with so much like creativity and technology and philosophy. What's really bizarre to me is they've been graphing these for hundreds and hundreds of years. I cannot imagine the first time they actually had a machine that showed a sound wave. Or like, I was with somebody yesterday, they had to have a CAT scan or an MRI, and all that imaging and radar and sonar and all that is waves, microwaves. Can you imagine somebody that knows trigonometry and they saw their first sound wave on a machine and they were going, are you serious? Now when Bryn's in the hospital getting her surgery, she probably had monitors that looked like this all around her.
They beeped.
And that's so aggravating. I've had them turn them off before. I'm like, I can't stand it.
Yeah, it happens because like
It makes
so
me
my
nervous
heart
wreck
rate-
for all that beep, 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 beep,
My
beep.
heart
You're
rate
afraid your heart
drops.
rate is gonna
Like,
like stop.
significantly overnight. It would go down to like the 50s.
Yeah.
And they like had a monitor on to like make it beep at 60. So like I would be trying to sleep and it would be beeping for so long, and I made them change like the limits. I was like, can you just move my heart rate to 50?
I just made him turn the sound off or ask, not that I can
It was
make
My
anybody
grandma,
do it.
like, she
Yeah,
was
they
in the
do it
hospital
here.
for 6 years. Cause she's like, I don't know, she's dead now. Like, she was like, she wasn't like functioning, but like, my dad just wanted to keep her alive for like,
Yeah, so she was
100
on life
years.
support.
yeah, and then,
Okay.
yeah.
Did she live to be 100?
Yeah.
Okay. But everything was beeping and there were monitors
Yeah, and
everywhere.
then like,
Your breathing goes over and over again, your heart rate goes over and over
It's so
again.
hard to sleep.
What were you gonna say though?
Yeah,
Yeah.
and
Is that
then
it?
we also were waking up every.
and then like,
couple
we
hours.
hire like 2 people to like care for her, and then for like 6 years, they like, every night, it's like that.
Was,
They got
but she
paid a
was in the
lot.
hospital.
I had to do a sleep study once, and I was in this room. There's some person like it was in one of those like kind of shared rooms because like
Yeah.
it got messed up, and there's like a lot of people there at the hospital that night. And there's this one. There's like a little baby who's like, oh, it was just so sad because it was on like self rock. They have like a baby bed and it's on self rock. But like it looks really contorted, so it's like this. And like we heard it next door, and my mom like looked through it, and it looked like it was just so sad. And you hear like all the beeping, and then it started
beeping.
crying. And I was like,
Aw.
it's like I was there the whole
They don't
time
know.
worried
Yeah.
about the baby.
Yeah, so your sleep study probably didn't go very well.
It was like a
That's
year
like,
ago,
I was,
yeah.
when I got my tonsils taken out, like, I started bleeding again, so I had to go back to the hospital.
That happened
And
to
so,
me.
yeah, so
Oh,
I,
Bryn.
Do we ever know?
No one.
but like the person I was sharing a room with, like they had, it was a little kid with cancer, and like, I guess they had been getting, they like, have had it for so long to the point where they knew how to like put their own IVs and all that stuff.
They get so resilient, it's
And
amazing.
so they were like, oh, like I can do it, and then her mom was like, oh, you want me to do it too, and like all this stuff. But it was just so sad because like she was so comfortable with doing that, that you know like clearly she had it for a long time, and like she had One Direction posters on her wall and stuff too. So it's like,
Well, that's
it's
like,
sad.
They're so, you can learn so many life lessons from those little kids. I've seen them go up and down the hospitals like riding on their IV, they're hooked up to chemo and they're like going down like a skateboard down the hall and, you know, they're so resilient.
Like the hematology floor, which is like what I've been dealing with the past couple of months, is also like on the
Kids.
oncology floor.
Oh, oncology.
So it's like hematology and oncology on the same floor. So like I'm getting all my tests done and everything with the oncology, and it was scary. It was really scary, but like I'm just thankful that
It makes you thankful.
Yeah.
They're so resilient.
Yeah.
So this weekend I'm running the St. Jude Marathon actually. So if y'all know about St. Jude in Memphis, it's like a phenomenal place where parents can send their kids and they don't have to pay. So it's like this actor Danny Thomas and his daughter Marla Thomas who've spent their lives bringing people from all over the world in to be treated at St. Jude. It's super cool, but it's so emotional. The whatever mile you run through the hospital grounds, it's got goosebumps, and like the patients and doctors and parents are out there screaming. It's like so rewarding, but emotional. Anyway, back to this. when somebody saw those first waves, I'm sure they were like, wait, we've been doing that for a long time. Like, we've been graphing trig functions, but we didn't know that there were these invisible waves going through the air. That just kind of blows my mind. That's really crazy. Like, even how this is working is based on that somehow. Somebody's captured all of this and made all this work so that she can hear me better.
So that's why like Bluetooth is bad, right?
What?
I think AirPods. I read this.
Oh, you mean because of the
AirPods?
waves and
Yeah.
cell
Yeah,
phones,
they-
maybe. They're
yeah.
going into our heads and we're
Yeah.
all wearing them, but anyway.
They actually, this is
If I
more
wear
in
them, they might be
chemistry,
able to
you know,
damage my
radio
hearing.
waves,
What?
microwaves.
If I wear AirPods, they might
Oh,
damage
they might
my
damage your
hearing.
hearing, so don't.
So I can't have
Yeah.
AirPods.
Just ask me.
Guys, AirPods.
Okay.
Use earbuds like with wires.
We'll go after.
Yeah, I can use those, but
better.
it's better to use like headphones.
Okay, so now,
Like it's like the Bluetooth and it can like, because it has these waves, it can affect it. I don't know. But all I know is that he told me I can't have AirPods. So.
AirPods are. I read an SAT like article and it's bad. So.
oh, about
That's what my parents said. My
AirPods.
parents were like, I don't want to get you them. And then I got them and I lost them.
there you
Oh,
go.
that
always happens, yeah.
Okay,
My dad
girls,
maybe third best.
back to this. Now, I hesitate to mention this because then it might evolve into stories of, myself included, of like rides at the fair. So let's don't go that direction right now. We're just gonna get on a merry-go-round, no, Ferris wheel, okay? So we're on the Ferris wheel and we get on this chair and here goes our ride. So we're riding on this chair, I guess it's face, okay, so we're doing this at Coney Island and then we go over and over again.
I've never been
If
on
the
Ferris
ride
wheel.
lasts, we're not gonna talk about Coney Island, I'm sorry I brought it up. The ride might last for a few minutes. And so I'm gonna graph it for 4 minutes over time, okay? Let's say that it takes, half a minute to get through a rotation. So at half a minute, what have you done? You got on the Ferris wheel at the bottom. You did not go like this, which is one thing I'm trying to stop you from doing. If you're looking at it, you're on a curvy. Sorry, don't want that.
It's like see-through.
Okay. Yeah, I made it transparent so I could actually write on it later when it really matters. All right, so anyway, girls, listen. If I graph this over time, in half a second, where will you be? Won't you be back where you started from? Okay, so you started down low, you went like this up to the middle, you came up to, let's call this, in fact, let me get rid of this. We'll start on ground level, we won't start below the ground. So we'll start on ground level, okay? And then we go up, however many feet until, let's say that the radius of this is 10. I don't know how big they are, 10 something, okay? So the whole thing's 20. That's as high as you can get. Do y'all see what I mean there? Please watch,
Yes.
okay? All right, so you're going in a curvy distance up to the middle of the Ferris wheel. So you're doing something like this. You get up to the middle, and then you go up to the top, and then you come back down, and then you're finished with your first part of the ride. And then what happens?
You go
You
again.
do it all again, and again, and again, and again. But if I'm drawing this to scale, and this, if a rotation is half a minute, and you do it for 4 minutes, how many times should you go around?
4 times.
8 now.
8
Yeah.
times, right? I have 1, 2, 3, 4, 5. So I haven't done this very well. So this would be 1 minute would be 2 full rotations. 1.5, this is just 2 minutes. And this would be 3 minutes, and this would be 4 minutes. And so I would have gone like this, sorry. It's not drawn very well over there, but y'all get what I'm saying?
Yes.
I would have 8 cycles. I would have gone around like this, but do you see if I stretch it out over time?
So each like
Over
7
time, you've gone like this. You've gone up and down, up and down, up and down. So do you see what I mean about, I'm sorry. Do you see what I,
Oh no, it's on the first sweatshirt.
that's okay, it'll dry. So y'all see what I mean about it's unwrapping it over time, okay? So there's so many applications of this girl.
It's
There's
squirting
waves going
on
through the
your
air right
Gucci
now
bag.
from all sorts of things. If I go downstairs and warm up my coffee, there's a microwave. If they do sonar to see if something's at the bottom of the ocean, that's sonar waves. There's radar waves. There's waves. Our heartbeats are rhythms. They're all over the place, and they're invisible, but we can grab them. Okay. One engineer told me, and I'll repeat this often just because I thought it was really profound. It's a friend of mine that's an engineer, and he was like with an electric company. Here we have Con Ed. It was like MLGW or something. The Con Ed of Mississippi. He was like the head of the whole thing. So I was like, wow. But we had started talking about electric currents. It's an electric wave. And I'm like, it's just really bizarre that I plug in something like my Christmas tree, and there's electric current going through all of that to turn on the lights, and then it's just really bizarre. I also have remotes to like turn things on, so there's waves coming through, different things to turn on the lights on the patio, and blah, blah, blah. So we're talking about how weird that is. And he said, you know what, I'll never understand it. He said, there's so much mathematics that we don't understand that we can't explain, but we can harness what's already there. I thought that was so profound. He's like, electricians or electrical engineers are trying to harness what's happening in the world, and that's what a mathematician does. That grows into physics and biology and chemistry. Is really mathematicians are trying to harness what's already there and create something out of it. Like a cell phone. They will actually work, and I can call someone. Someone texted me this morning from England. I'm like, that's really weird. I wish they had done it at 4 o'clock in the morning. I don't know what time it was for them. But y'all see what I mean? I'm like, that's so weird if you stop and think about how that all works.
I think like on FaceTime, like that's so weird to think
It's
about.
just so crazy. Yeah.
There's sound coming out of your phone that people.
And you can see them in real time.
It's just so
weird.
It's just a lot to take in.
It's a lot to take in because it's so bizarre, and like he said, we just try to harness what's happening.
Also, I was gonna get like this like friendship light where it's like in my room and I could like touch it and like change the color and it would change in the other person's room or like wherever they are.
Oh, that's so fun.
Oh, yeah, there's this thing also that I saw. I think I saw it on like Instagram or something. It's like a watch that it's like a touch watch. So you
Yeah,
like touch
so
it,
you can
and
touch
you the person who has the other watch can like feel like themselves being touched in that like a pulse on the watch.
Oh
Like,
my goodness.
So like it was like a story. It was like, oh, I got this for my boyfriend got this for me too, so I know when he's thinking about me, and he would just go like that,
Yeah,
and he would just like feel it like
Yeah, touch
the
myself.
other person feel like
Oh.
Well, I bet if I
Yeah,
send
yeah.
one of y'all my
Yeah, I don't
digital
really have
heartbeat, I
one.
bet you would feel it on your watch.
Could you?
Like I can feel it on my watch when I do it.
Oh, yeah, for sure.
But if I send it to someone else with a watch, I bet they feel it when they receive it.
You can send a digital heartbeat.
Yeah, I send one to my husband all the
No,
time.
it's like an echocardiogram.
But he doesn't have a watch, so I think he can't feel it on his phone. He just sees it going do 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 do.
Which is, like,
I'll show you
so,
it.
like, you can feel someone.
Have you ever seen one?
So they have
I don't
like
think
a
I've
small
ever used an Apple Watch
echocardiogram.
I don't think I have either.
Yeah, I was
Me
thinking,
either.
like,
I'm
Say that again?
Echocardiogram. It's like
wouldn't wear one.
a thing.
Like he wouldn't wear a bracelet, so I was like,
Echocardiogram.
Are you talking about an app or?
No. It's like they use it in hospitals.
Oh, in hospitals, yeah.
And echocardiograms is basically like a smart.
All right, so here it goes. So since it's on my body, it's going to pick up my pulse. So we're sending my husband a heartbeat. Let's see. So I hit the little heart, and so I'm going to do this.
What the heck?
you feel it?
It's not working. No, it's just sending him crazy stuff. Like my heart's not. There it goes. I don't know. Can you feel it? Put your hand.
Oh yeah.
Wait, I want to
So here it is.
Oh my goodness.
This
Is
is-
it weird?
Yeah. Oh my god.
Oh, wait.
Woo, that's so weird.
Wait. And that's what you get if he sends it to you?
just
he
touch the
can't.
heart?
He doesn't have a.
Oh,
Well,
okay.
it just quit.
Oh, sorry.
Let's see if it'll start again. Keep.
Is this what doctor?
I don't know what. Oh, there it is.
Here, can I? I'm gonna.
Oh gosh,
Isn't that
that's
cool?
so interesting.
Hey, girls.
That's literally what my neck sounds like after a bunch of
Stairs.
Yeah.
Yeah.
See, that's where it counts.
Okay, so back to this. And there are things that. Shh. I will be adamant about, that I should be adamant about, so let's continue on. All right, so Julia, the next one must be
Wait, what are we on?
5 pi over 4 maybe?
Yeah, 5 pi over 4, negative 0.7.
Comma, negative 0.7.
Yeah.
Okay.
The next one is 4 pi over 3. And that's negative 0.86.
And it got really old just probably writing down the same things over and over again. Do we have 3 pi over 2 now?
Yeah, 3 pi over 2 and then negative
2. That's at the very bottom, so that one's negative 1. All right, and then you're going to hear the same numbers again. So now we're at 5 pi over 3?
Yeah, 5 pi over 3.
Oh, Desmos. Okay. 5 pi over 3.
Negative 0.86.
Okay, I think that's enough. She could report it. Now what happens is if we just kept on going into past 2 pi, you get really aggravated because then what would happen?
Goes back up.
It just keeps doing the same thing over and over and over again, okay? But it should be a learning experience if you and your partner feeling like, wait, I'm hearing the same numbers just in positives and negative fashion because of the reference angles. All right, now we learned from this how to graph y equals sine x. Did y'all see it, girls? Ooh, look up here. All right, so here's y equals sine x. And so once we get one cycle, we're done because the cycle just repeats itself over and over again. Do y'all see what I mean? Okay, so we're not going to do that anymore. We're going to do this. However, you have to do it right. You can't do it like Charlie Brown's sweater, okay? We can have no Charlie Brown sweaters. Do y'all know what I mean by that? Like Charlie Brown's t-shirt has those like V shapes. No Charlie Brown sweaters. But why find all of those points if I could teach you just to find the start, the high, the middle, the low, and back to here again. All right, so what we're gonna do is this. I'm gonna turn this one off, and this one off. Okay, I'm gonna get rid of this one, and this one. And I'm gonna get rid of this one, and this one, and this one. And this one, and I'm gonna put in the end 2 pi, which was 0. All right, do y'all see those 4 points in colors there? So the last time that you had to, the last class where you were like, I don't want to do this, and I had to like really be grouchy about it and make you do it so that you would learn when I wanted you to learn, and also so you would be thankful that you don't have to do it ever again. All right? Because the highest number you got in your little chart, she was saying 0.7, 0.8 was 1.
Yeah.
Okay? The lowest thing you got was negative 0.7, negative 0.8, negative 1. Okay? And so we're just going to find 5 points. We're going to find 5 points, and then we're going to connect those dots in a wavy fashion. Watch, girls. Did y'all see what I mean? Okay. All right. Now, did anybody know what happened when, let me get rid of this because I don't want it to happen. Do you remember what happened when I started putting numbers in front of it instead of just ones? It could change the frequency or the amplitude. Okay. And it could go the opposite if I made a negative. Okay. So if you know the basics, it's easy to change it with the transformations you learned in Algebra 2. It's exactly the same. I need to remind you of those, okay? If I put a number in the front, it causes a vertical stretch or shrink, okay? And it does exactly as it seems. If I put a 3, it's going to stretch at 3, all right? If I put it in the middle, like right next to the X, it's going to do the opposite of what it seems. That may sound somewhat familiar to you, and I'll explain that. Let's put this X in here. Now, if I put a 3 right there, it's going to change what we call the amplitude. You've all heard of amplitude or amps before, okay? And actually, instead of this is, always taught in a co-ed school until I came here. But instead of frequency, it's actually called period. And it's cyclical, and it happens over and over again. And there's just so much there that is uncomfortable in a co-ed situation. But it is like that, isn't it? If you think about different types of periods, okay? So anyway. So watch 3 sine x. Oh, let me change this and zoom out. Okay, you ready? Watch what happens to 3. This dot right here was at 1. Now where's that dot?
3.
At 3. This dot was at -1. Where's that dot? -3. The zeros are still the same. All right, Ava, what's going to happen if I throw a negative in front of it?
It's gonna go the opposite.
It's going to flip it over.
Yeah.
And so then Ava and I know to go down 3 first, so we can start to crank them out faster. And again, that last activity that I gave you before Thanksgiving, hopefully you don't have to do that anymore. Hopefully you know where to find and how to find it, okay? Now let me show you, this will change the frequency, or really it's called the period of the graph, okay? I'll explain why some people call it frequency. By the way, y'all have heard of AM and FM radio?
Yeah.
Okay.
Do you want
There you go. Oh, thank you so much, Kate. That was like, how did you know that? Okay.
What? Wait, what'd you say?
Amplitude's modulated.
Power.
Modulated.
Miss, hey girls,
Okay.
I'm going to put in a 2, okay, next to the X. Oh, by the way, what you don't know yet is this, whatever happens right here, if this is a 1, the period is just 2 pi, which is out here, right there. Watch.
I like.
Hang on just a second, just
Okay.
because I really have to finish this, okay? Try to remember what you were going to say. Do y'all see that it goes like this till 2 pi, and then it's going to do it every 2 pi radians. So the period of time it takes to complete a cycle is 2 pi, okay? Now, this number dictates that. If it's 1, it just has what's normal, like 360 degrees. Does that make sense? Or 2 pi. Okay, girls? Please watch. You don't want to miss this, okay? All right, now, I think logically, I would think at first if I put a 2 in front of x, it would stretch the period out longer.
No.
Okay? But if I change this to 2, it actually shortened the period. Let's see what the period is now. It's not. Do y'all see one cycle is a down and a up? Let me get rid of the negative. So here's an amplitude, and here's the period. Okay? What is this dot? Where did that come? Oh, it was left over from the other graph. Just ignore that.
How much did it shorten?
All right, hang on just a minute. I'm going to show you. Now look at the end of it, Anya, is pi. And so the other one used to take to 2 pi. Now the period's pi. I'm going to show you how to find that. Okay? So what's going to happen here if I do 4 and I get rid of that 2, it's just going to have a period of 2 pi, but it went up 4 and down 4. Now cosine, you also graph some cosines. Cosine looks very similar, but do you see that it starts up at the amplitude?
Oh.
Okay.
Yeah.
Do you see it doesn't start at 0, it starts up high?
It just starts.
Let me show you the reason for that, and then we'll take some notes before we leave. Okay, so this is what's happening. All right, if you're on a circle or on a Ferris wheel and you're going around like this, okay, right here, that's your x-coordinate. Your y-coordinate isn't even there until you start going up. Do y'all see what I mean? So sine starts with no y at all. That's why sine starts at 0, 0. Okay, and then you go up into the positives, back through the positives, and then down into the negatives, and so on. Do y'all see what I mean? I think in common sense, one rotation would be 360 or 2 pi if it's left alone, unattended. Okay? All right, so that was sine x. All right, if I do cosine x, cosine, you know, is x over r. What is happening to your x-coordinate? Right now, your x-coordinate is the exact same distance as your radius. So it's a 1-to-1 ratio. You start way out here. And then your x is still positive, but it's getting what? Look at that x-coordinate. Isn't it getting smaller? Until your x-coordinate disappears for a minute at 0. At pi over 2, you get 0. Then what is your x-coordinate doing? It's in the negatives and it's growing, isn't it? Until it gets to -1. And then you get the same x's all over again. And then what do your x's become in the fourth quadrant? Positive again. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay? All students take calculus. Do you see how it's positive in the first and fourth quadrant? All right. So how are we going to do this really fast? And we'll write something on our memo page about it later. Sorry, that was just for another class. I don't want to do this. Okay, so if I have y is equal to 4 sine 2x, this is how you're going to graph it. This number right here is going to give you what we call the amplitude. Amplitude technically is always positive. It just means a distance above and below the midline. 0 right now for us. That will change sometimes. Okay? But the amplitude is if you're going up 4 and down 4. Now, like Ava mentioned, if it is negative in front of it, it'll just make Ava and I turn our graph a different way. But the amplitude is just how far it's varying from the norm or from the middle. Okay? The period, a normal period of a graph, I think we'd all agree should be 360 or 2 pi. Okay? If I throw something in front of it, what's happening is this. X is usually time in the real world. Okay, girls? X is usually time. And if I'm at a boxing class and I'm just punching the bag, and then the instructor goes double time, do I then go even slower? No, I go like this. I go faster, right? So do you see how it speeds up your graph? The 2 is giving you double time. It doesn't go, oh, I'm going to go really low and just wait. If they said half time, I guess I would start going half the time that I was doing before. Okay?
0.5x.
The way to find the period,
Is amplitude
and we're gonna, amplitude is this way, period is how long it takes it to complete the cycle, amplitude is how far away it goes from the average, from the midline. Okay, period, you're always gonna say 2 pi, you'll start with normal, and then you'll say 2 pi over this number. So now the new period is pi. I'll say this to you a lot in the next few days, 2 pi over, 2 pi over, 2 pi over, 2 pi over. Now, the first ones you did were 2 pi over 1, so the period was 2 pi, okay? All right, so now I'm ready to graph. All I really need now are 5 main points. Watch my fingers. I'm going to use my fingers a lot in the next few days. You're going to need a starting place, and then 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. Watch my fingers. You're going to need to know where to start. And then high, middle, low, back to middle. Does that make sense? And then we'll draw it curvy so that you don't have to find all those other points, right? Don't go straight up to the top. Remember, you curve up to the top, okay? All right, without any of those charts, which is fabulous. Sine is the one that starts right here. And I'll be using, I'm sorry, that should be at the origin. The board's sort of messed up. I hate to hit the undo button because it might undo everything.
It went in. Loud.
Wow.
Anya, name a teacher's class that you would not do that in. Or name a teacher's class you would do that. Oh, we didn't go it very far.
No, I just
Yeah.
accused it.
I think it'd be really fun to get to throw it across the room, actually.
I've done that one.
I've done that. I done English
think
I have
biology
it.
every day. And
I
it's
did
such
that
a
in my
risky
thesis
game.
class last year and she yelled at me.
Yeah. Well, you shouldn't do it. I just
Yeah.
personally think it's
She likes
Oh,
to
Miss
grab that.
Okay, girls,
Yes.
back to this, because this is real
Yeah,
important. This
we
will
would
be your
have to-
homework. Hello.
Sorry, yes.
Okay. So, anyway, the period is pi. You always divide the period into 4 equal parts. Take this chunk of time and divide it into 4 equal parts, because you want 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay? So I'm going to count by pi over 4. So I'm going to go 1 pi over 4, 2 pi over 4, 3 pi over 4. What's the next one? 4 pi over 4. Do you see how I ended at pi?
Yes.
Okay, so it's going to tell me where everything super important happens. Watch this. I'm going to go up 4, 1, 2, 3, 4 from the middle. Okay, okay? Sine starts right here at 0, 0. At the first mark, sine goes up, middle, low, middle, and you've got one period, and then you can easily graph more if and when I ask you to. It just repeats itself coming and going in that fashion, okay? Now let's look at this at Desmos. 4 sine 2x.
I appreciate
I'll
the
be
use
like
of Christmas
50.
colors.
4, I love Christmas, sine 2x.
Yeah, what I was gonna say is I remember the Desmos project that we had in freshman year, and it's like I was using like these
Transformations,
functions. I was
yeah.
using like sine and stuff.
Well, really,
And
everybody did it,
I'm
and
pretty sure
they.
it's like a star where I did like the X's.
Hey,
and
girls,
all the lines.
we just did this, okay? The period of time, look up here. I don't know what people are doing that aren't looking, that's scaring me. The period of time that it took it to complete one, do y'all see
No.
one cycle is pi?
Yes.
And also look at this dot, pi over 4, 4. Let's go back to our notes. Pi over 4, 4. Do y'all see that? So it's a great quick way to graph. Do y'all see I did get the important points? Let's go back to Desmos. This little low point right here is 3 pi over 4, negative 4. Is that what I have drawn in my notes? 3 pi over 4, negative 4. Do y'all see how it works? All right, so let's do another one. So now I'm going to do y equals, get rid of this. Now, like Bryn was mentioning, and like a lot of y'all suspect, I don't know how to get rid of this.
I think I could do that.
Yeah, you might have to stick the down arrow.
There. Let's go to another slide. As you probably suspect, we're also going to start, you all did the function art project she's talking about most likely, where you made like some sort of Christmas picture or
Subway, Boston.
subway, something, anyway. We are going to, girls, take these graphs left, right, up, and down. Right now, we're just leaving them stable and we're stretching and shrinking, okay? All right, so now let's do y equals negative 3 cosine 4x. All right, the amplitude is actually 3 because it's just a distance from the middle, going up and down 3. However, when we start to draw it, we'll go down, okay? The period, 2 pi over 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 4, which is pi over 2, or 90 degrees. By the way, the reason we graph it in radians is when you use your calculator, you just don't have to put in you don't have to change your window a lot. Girls, if we were in degrees, we'd have to go out into the hundreds of degrees to see something. So radians is more efficient. But you could graph them in degrees, I don't care.
Is it
Okay?
always
2 pi over 2
whatever?
pi over, because that would be the norm.
Yeah.
Okay, so then they're not lengthening it by 4. What happens is there's the opposite of what I've seen, so that's why I divided by 4. Then what you're gonna do, girls, is always divide this into 4 equal parts. Watch this. Pi over 2 divided by 4 is super ugly, right?
Yes.
So I'm going to take a fourth of it instead. Isn't that the same thing? All right, to where a lot of you taking notes or you'll look back, you'll write on your memo page, you'll memorize this. However, I want to make it make sense. Remember, the chunk of time it takes to complete itself is pi over 2. And I always want to divide that up into 4 equal parts, right? A place to start, and then 1, 2, 3, 4. So that makes sense. I want to take this chunk of time. Think of how many things in our life are like that. How many times in your life you've heard 1, 2, 3, 4, 1, 2, 3, 4. What are the seasons? In our year, how many are there? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Watch this.
Season 3. I like season 3 too.
In January, it's cold. So let's say that this is 50 degrees is the norm. In January, it's cold. What happens in the spring?
It's average.
What happens in the summer?
It gets hot.
What happens in the fall?
Down again.
And what happens next winter?
Cold. Global warming.
Well, now climate change.
Pretty
Oh,
cool,
so
right?
relevant.
Alright, so let's go back to where I was.
Would it be like just like a like
Greta.
Like that. And then
You know,
Wait, what?
it goes like this.
the curves
and then
will be
it's gonna
smaller.
down.
Such a good slogan.
Okay, so this is what you always do.
And then it'll beep. And then the earth dies.
Oh my God.
Amplitude's gonna be the number in the front. Amplitude's gonna be the number in the front. This is gonna affect the period of the graph, and you say 2 pi over 2 pi over, okay? Once you get the new period of the graph, you always divide it into 4 equal parts. Either divide it by 4 or cut it into fourths, okay? So now I'm gonna draw my graph, and so I'm gonna count by pi over 8s. So I'm gonna go 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. I don't even care if you reduce or not, if it's easier for you just to count. However, what is 4 pi over 8? Which is where I should have stopped, right? I'm gonna go up 3 and down 3. Now watch this last thing that I'm gonna do, and then we'll go to delta math before we go. Here's the origin, okay? Sine starts there, cosine doesn't. Cosine starts at the amplitude, okay? However, I'm not gonna start at 3 because this graph is what? Negative. Do y'all see what I mean? So I'm gonna start at -3, and then I'm gonna come to 0, go up to +3, back to 0, and down low. That's what your 1, 2, 3, 4 is about. Cosine will start at this number. Sine will start at the origin and go to that number, okay? So then you'll draw it wavy, and then I may have you draw like through 2 periods or something of the graph. Now look at delta math with me. I think I already have it open.
Oh, look at it with you on our own.
No, I'm sorry, up here with me. So I already have it loaded. So this is what you'll see right here, okay? All right, so this is really fun. 7 sine 7x, but you would have to have me tell you how to do this, so everybody actively watch, okay? X-axis label, I'm just going to count by ones. And the y-axis label, I'm going to use pi.
Oh, you're writing that in the x-axis label.
Oh, thank you. I don't want that. Thanks. X-axis label's 1. Oh, no, I do want that. Okay. The y-axis, I'm going to go up 7 and down 7. Okay. The period of this is 2 pi over 7. So we'd probably go off and write something 2 pi over 7. And let's try making this. I can't remember how to do it myself now. 2 pi over 7. All right, so and graph 1 cycle. So now I'm going to go up 7 and down 7, back down to the middle, and then down 7, and then back up. It's a positive sine graph. All right, now it may not be right yet because I've forgotten how to do this. I can change it. I wanted this to be 2 pi. I think I made each mark 2 pi over 7. I think I need to change that. So what's 2 pi over 7 divided by 4?
Times 1/4.
Oh, I may have to reset. Let me reset.
Over 28.
All right, so x-axis label is going to be 2 pi over 28.
Well, that would be.
So that'd be pi over 14. Okay. So pi over 14 is each mark, and I'm going to go up and down 1. So let's try that. Okay. So now I'm going to start here. I'm going to go up 7, come back down. I'm going to go down 7 and back up. And that should be it. What's happening? Pi over 14. 2 pi over 14 is pi over. No. On the axis, I don't know what I'm doing wrong.
You must answer all. What does it say?
Yeah, but usually it lets you do it there. Did I miss one of my points?
No.
7. That should let me do it.
Give up.
Yeah.
That's what I was doing. Like, here we go.
All right, so the period's 2 pi over 7.
Isn't that what you had originally?
Yeah.
Ours was a little skinnier.
Let's see.
It was a little skinny.
2 pi over 7. Well, that's because I didn't skip 2 spots, so that should be okay. All right, so now let's do another one. Do we have time?
I don't.
Next problem. All right, so 5. So we're going to count this by ones. And let's just try 2 pi, 2 pi. Girls, right now it's 2 pi over 1. We'll figure it out before we
Wait, so
go.
Are we always supposed to do it as 2 pi?
No, right now, Ava, it's 2 pi over 1. Okay. So I'm not sure. Oh, okay, that's what I did wrong. I should have put that dot where I wanted it. So I can put 2 pi wherever I want to. I'll put it right there. All right, it's cosine, so it doesn't start here. It starts up at positive 5. Then it comes to the middle. Then it goes down 5. Then it comes back to the middle. And at the end, it ends up at 5. And then, do you see, you'll know you got it right. It lets you submit the answer. But I always forget what I'm supposed to do for my axis. So let's do another one. And, all right, so
So satisfying.
this is going to be count by ones. And the x-axis label, I want to be 2 pi over 6. Girls, listen. Or pi over 3. I clicked on the pi and it put it in there for me. But then, so I hit done. And then you can put this wherever you want to and skip however many spaces. So if I didn't want it to be all, but you want to count out like an even amount. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, like that. All right, so that is the end of the period. It's cosine, so do I start here or up at 5? Very good, up at 5. Then I'm going to go over 2 because of where I put my end. Then I'm going to go down 5. Then I'm going to go back to 0. And then I'm going to end at 5. And the good thing is that submit answer will pop up if you did it right. Okay? So in answer to some of your questions, I could grab that pi over 3 and drag it way over, but then I would have to skip the appropriate amount of squares to make it happen. Y'all okay with that? So your homework's a memo quiz and this fun Delta math. Okay? Thank goodness I did it with you. Bye, girls.
Will the memo quiz be on this?